I am not super fast Matt, but this video will feel like a super fast Matt video. I'm a weird race car guy, and I build weird race car things. I also don't like my neighbors. So I thought, what kind of weird race car project could I do that would also help me get even with my neighbors? An engine dyno. That will solve all my problems. When I first started this project, I had no idea it was going to get me banned. I'll tell you more about that drama later in this video. Before I start any project, all of my ideas must meet a 4-point system before I do them. The project must be cheap, easy, fast, and stupid. This chapter of the story is about point number 4, stupid. I don't consider myself to be a genius. Smart maybe, but definitely not a genius. So all of my ideas need to be at my level, and to some extent, my audience's level. One way to load an engine is to use a water brake, often referred to as a water brake dyno. Another type of dyno is an eddy brake dyno. These dynos use eddy brakes that can be found on semis and trains, and they're called eddy brake dynos. There's a trend here. Engineers can be very pedantic when it comes to naming their ideas. This last type of dyno uses mechanical brakes, like the ones you would find on any car. What do you think those dynos are called? That's right, prony brake dynos, spelled P-R-O-N-Y. Not pony like a horse. It's named after the guy who invented it. Very logical, very engineer. This is the one I will use. You just saw us build the frame to support everything, and we added wheels on it so it rolls around easily in the shop. If you want to make something like this, just do what I did. Buy your local raw materials from the scrap bin. Whatever is in the scrap bin, you use, as long as it's very big and very heavy. If the scrap bin, or sometimes scrap pile, at your local metal supplier does not have any big heavy things in it, then you can use a very large amount of small things to make a big heavy thing. If the local scrap pile or scrap bin does not have anything useful in it, then just go home. Today is not your day. Do not spend good money on this project by buying nice new materials that are big and heavy. Remember, this is a stupid idea. Now that the engine is on, we need to solve a few basic problems. First is that every engine dyno needs a lever. This is where the torque numbers come from. The second thing we need is a means to apply load. That's the brake portion of the dyno. Third, we need RPM, and we can get that from anywhere, it doesn't really matter. The fourth thing you will need is a data logger. In our case, we're going to start with an oscilloscope. We already had the oscilloscope, so it's technically free, and it can record data at extremely fast rates. The stupid part of this project is happening right now, just in case you didn't catch it. There's a brake rotor and caliper from a Silverado, and it's being bolted directly onto the crank of the engine. The throttle and brake are actuated manually by hand, and we position the operators only 4 or 5 feet away from all the danger. Remember when I mentioned that this project got us banned? Let's see why. Cheap, easy, fast. An engineer's equivalent to a hole-in-one. I'm not just a weird race car builder, I'm also a broke race car builder. I'm also very busy chasing the neighbor's dogs off my property, and working, and trying to get 10 other projects done, and film those projects for YouTube, Instagram, and a DIY Engine Dyno Facebook group that I thought would be helpful, that I thought would appreciate my effort and my creativity, and contribute to the problem-solving fun of this project. But no, social media has not been kind to me. I am a lot of things, but a petty engineer who argues online, I am not, so I won't point fingers. But here's a screenshot of the Facebook group that banned me. So you all can go and sign up and repost all of my clips to remind all the members there that no, this stupid idea does actually work, and no, it's not going to kill anybody, yet. And that I was right, and they were wrong. You can do that. Because I am not petty enough for online arguments. Directly. Anyhow, where was I? Oh yes, I want all of my projects to be cheap, easy, and fast. Why would you want it any other way? An expensive, difficult, and slow project doesn't sound like any fun. Cheap. The one thing this project has going for it. Compared to other DIY dyno builds, this project is actually pretty affordable. The frame is made out of scrap metal, the brakes were from a Silverado that I bought off of Amazon, and the other custom parts weren't too expensive or difficult to make. And we just used a couple of inexpensive sensors and connected it up to my oscilloscope. So far, the project has only cost $3,000. Most DIY engine dynos will easily be double that, and you'd have to use a whole lot of used parts to hit that price target. Most new builds are easily over $10,000. If you go shopping for a brand new engine dyno from a reputable source, all of the websites say request for quote, which is a polite way of saying if you have to ask, you can't afford it. But the internet says that a new one will cost you between $50,000 and $100,000 depending on the amount of horsepower you need to test. And I can believe that. This project is definitely cheap for now. But as you saw in the clip that got me banned, it did not work. It was $3,000 to make a stupid idea that doesn't work. So let's put a solid rear axle on it that we got from a questionable junkyard. Yes, I said questionable, because it was listed on Facebook Marketplace as a GM axle, when in fact it is actually a Ford axle, specifically from an F-250. As they say, you can trust everyone on Facebook Marketplace. The guys at the junkyard were pulling apart trucks that they claim were legally acquired, either through insurance auction or private sale. You can trust everyone on Facebook Marketplace. The axle solves a few important issues. Are you not entertained? One was the RPM. The brake rotor was previously spinning at RPMs it was never intended to. And that was causing friction problems and made it very difficult to control, and almost certainly we didn't have enough braking force to overwhelm the engine. And believe me, we tried. We gave it all the braking force and all the RPM, and that brake caliper could not win that fight. Yes, the axle does have a ring gear, and that is going to multiply the torque, but that only applies to the caliper and the rotor, which you'll see later on in this video. Those forces get canceled out, and the load cell will only see the torque that comes from the engine, which is what we want. And it was cheap, only $300, and some custom adapters, and some new fluids, and make some fresh mounts. But will it work? Easy. So far this project has been easy. No special machines were needed, no special heavy lift equipment was needed, just my handy engine hoist. All the electronics have been things we either had or know how to use, and all of the work just used basic fabrication tools we already had. So yes, this project has been easy. Right until now. One big problem with having a cheap goal is that it often requires you to do things that are really stupid, and to find out the hard way that that doesn't work. But at least it was cheap. There is one really good thing about this method, which is that on very rare occasions, the cheap stupid thing works right away, and that feels good. It's the engineering equivalent of a hole-in-one. Just swing really hard and hope that the ball makes it in the hole first try. It never really happens, and most people never expect it to happen, but we all keep trying. Because one day, maybe, it will happen. And when it does, it's truly amazing. That day is not today. Not for us. Kind of like the lottery. Somebody always wins. It's just never you. What started off as just a few months of work very quickly turned into an engineering deep dive. Enter my neighbor Mark. Mark is a good neighbor, but because he's smart, he's really smart. Smarter than me, but not much smarter than me, because he's standing right here next to this death trap that got us banned from a Facebook group that shall not be named because I'm not petty. The electronics were not working, and operating the brakes and the throttle manually was proving to be too difficult. We needed something better. And better means more time, more money, and more difficulty. All the things I don't want in a project. Fast. Mark jumped right in, adding an Arduino controller, hooking up to the sensors, and Mark used AI to help him write some custom code to work it all. We decided we were going to work the brake using an air cylinder. This was stupid, but it was cheap. The idea was simple. We were going to rev the engine to the moon, apply the brakes, and use the controller to regulate the brakes to pull the engine down. That was it. That was all it was supposed to do. Let's see if that works. Test after test. Months went by, and what started as an Arduino controller graduated to a Raspberry Pi. What started off as a simple on-off circuit turned into a stepper motor regulator circuit. It got complicated, and we were running out of patience. It was supposed to be easy. It was supposed to be fast. It was not. At least I can say I was getting even with my neighbors. Finally, we caved. We spent over $1,400 on a proper dyno controller from the wonderful people at yourdyno.com. It came with fantastic software. This stuff is next level, but it was expensive. Mark had to design a new hydraulic brake actuator. We needed more precision. The air-operated system just wasn't giving us the speed and precision that we needed. So Mark designed a cam-operated hydraulic master cylinder, and that was going to work the brakes. And to get the precision that we needed, we used a stepper motor. This gave us all the force and all the precision that is required to control an engine precisely. Good job, Mark. All we needed after that was a couple of trash cans and some garden hoses. It still needs to be stupid. The rotors made a lot of dust, and they got really hot during testing. We need to fix that. Adding 2 trash cans to cover up the brake rotors made it easy for us to contain the dust, and adding garden hoses with some nozzles on them would spray the whole system with water. This would help collect the dust, and it would help keep the system cool so we could run the dyno for longer periods of time. And they worked. First try. Finally, something that was cheap, easy, and fast. That actually worked. And it's still kinda stupid. Let's see how this does.
That was it! Woo! Finally. It's almost like we know what we're doing. Ah!
And there it was, a steady ramp-up pull, controlled by the software and data logged appropriately. It finally works. It was stupid. It got us banned, and it failed a lot. But in the end, now that we've built it, it is easy, and it is cheap, and it is fast to build. But only after we've made it all this way. But we only get to say that in hindsight. The road to success is only knowable after you've traveled it. After 12 months of hard work, we finally have an engine dyno that pulls. And I can safely say that I am even with my neighbors. If this is something you would be interested in, and you need to get even with your neighbors, you can click on the link in the description. That will take you to my website where you can sign up for a waitlist. I will be offering this as a kit in the near future, and there might be plans down the road. We still have calibration and other testing to do, so be sure to like and follow. And if you don't, I might move next door to you and run the engine dyno all hours of the night and twice on Sunday. Superfast Matt did not approve this video.